Hi, I'm DJ Ware. On this episode of the CyberGizmo, we're going to be looking at LXD and Lexi in a little bit more detail than we did the last time when we talked about virtual machines and containers right after this. So I wanted to do a little bit more in-depth view or look into LXD and Lexi. And before we do, let's review a couple of things about what the architecture of LXD is. Well, Lexi is the container, and LXD is the virtual machine-like layer, which provides similar features that a virtual machine would, but it's much lighter weight to a full-size hypervisor. And it allows a layer of isolation between each of the containers, as well as from a layer of isolation from the host operating system as well. So that's really kind of what it's intended to do. And we had talked last time about, that LXD is an open source container mechanism. Ubuntu is the major contributor to Lexi and LXD. Canonical offers commercially supported Ubuntu LTS releases that have this built in. And then the features are, it's better security. It allows device pass-through. It allows for storage pooling and snapshots and all these kinds of things. If you want more information about this, go see my video on virtual machines and containers, and I'll include a link below. But, it's not meant to be a replacement for Docker or Rocket. So, I guess probably the best thing to do here is maybe just jump in. So let me go over to a full screen view here. Let me just take that away. And so, yeah, there we go. So the first place you can go to find out more information about what containers are available to you. Now, you have to remember that this is a little bit different than the way Docker does it. Docker's approach to this is to provide applications as well as operating systems, because you can install operating systems in Docker. But they do both. They allow you to deploy applications, whereas the image server for Lexi and LXD is, at this time, solely operating systems. And there are a number of them, as well as a number of architectures and a number of versions. So some of the ones you can deploy are Alpine, and like I said, lots of versions, lots of architectures. There's also Alt, Apertus, Arch, and CentOS, of course. And there is also the Stream version, as well as the straight 8 version of CentOS. There's Debian in all of its flavors. Let's just go down and get a couple others. Fedora, Gentoo, Kali, Mint, OpenSUSE, OpenWrt, Oracle, which of course is a version of Red Hat, Sabian, and Ubuntu. Also, Void Linux is also a member of this as well. So yeah, you have a lot of different. You could pull a lot, and this image base is growing. By the way, it's not static. It is still growing. So what I'm going to do today is just make sure that everything is working on this side. Yeah. Okay. So let me bring this up a little bit larger. Oops. Okay. So I'm going to be using Pop! OS to do mine on today. Of course, this will run on Ubuntu as well. But the first thing you'll want to do is to install Snapd. It's the easiest way to install this. There are some different ways to do this directly with the APT packages, but to get the latest versions of LXD, use Snap. You can always get rid of it later if you want. But I've already got it installed, but I'll go ahead and go through the motions. Oops. Okay. So yeah, I've already got it. So once you have that done, and again, I already have it installed as well. You can also do a snap list once it's installed, and it'll show you the version and all the information that you need. The other thing is you'll want to look at is in your Etsy group. You'll notice that right here there's a LXD group, and I've already added the user that I'm going to be doing today, but you would do a user mod, AG, and then put in LXD, and then whatever the username that you want to use with it. So, yeah. And then all you would do is log back out and log back in order for the group to take effect, and then do an ID to make sure that it indeed is. Sometimes with certain distributions and services, sometimes you have to restart the actual machine in order for it to get to work. But in this case, it did not have to do that. So let's look at another couple of things that we need. We're going to need some disk space in order to host the containers. So make sure you have enough to be able to host the container, whatever the minimum is for the particular one that you're bringing down. I should be okay. I have plenty here. So the next step would be to do an LXD init. This is only done one time, and it's used to initialize the environment. Now, if I just enter it like this, it's going to stop and ask me a bunch of questions. If I want to do the defaults, I just do a LXD init all, and then it'll just take the defaults. I think that's right. Let me make sure. Yeah, see, it's asking me that if I want to use clustering and that kind of thing. Let me see if I can just do a help init. It'll tell me. Auto. I want to do auto. So, which would then take the default pass. Otherwise, it's going to ask you to fill out all of it. Once you've done that, and you have it in your group, you should be able to just run this Lexi, which is the container side of things. And you'll notice there's a lot of different commands in here that you can do. So let's see. Let's take a look at remote. And these are these would be the sources for the images that are currently installed on the system. And also you can, hang on a second. Okay, so the other thing I want to do is an LXC image remote list. This will list the remote images, and I can start it with a key. Let's see, let's try it with E. Oops. And it'll churn around and look for the ones that are out in the repositories and then show me. So this will tell you which ones that you can use, and normally you just use this field to find them. So that's how you locate them. It's a Lexi image list, Ubuntu, and then you can put in wildcards, like I can search for all the ones that are EON. And it'll show me the ones that have an E in it. So I don't know why it didn't. It brought them down again. So anyway, not sure why that is. It shouldn't do that. But all right, so let's do LXC help. Projects are used to organize a bundle of containers into a group that you might want to keep together. So say like you're a cloud provider and you have a number of clients, you might use projects as a way to segment the containers one from each other so that you can keep track of which ones you've created and which containers belong to which customer. Ubuntu has a tutorial on their website that I'll post a link to below if you're interested in pursuing that kind of organizational detail. But for today, let's see, I think all I have to... Yeah, so I can list the projects, and my current one is default. You always have that one as your default, and then you can create the ones you want, and then you can then log into those projects and continue working on them. So today I'll be working in the default project. So we'll do a launch, and we're going to do Ubuntu. Let's do 1804. I guess I use the last LTS since. And then you'll want to give it a name. So I guess since we're going to build a web server, we'll call it web server. Now this will take some time because I took the image off, and so it has to transfer just like it will for you. This is a one-time transfer. Once you have the image, any future containers you build from Ubuntu 1804 will use the image that's there. Very much like Docker. Very much like Docker. We're just waiting for this to come down and then install. Okay, so at this point, I can look and see that the container is, what the web server container is running. It has an IP address, it has an IPv6 address that was given to it, and then it tells me that the type is container, which, yeah, it would be. So at this point, I can actually execute commands on that server. This -- is for what shell I want to use, so I'm using the default. apt, I'm going to do an update. We'll check and see what updates are available for this. Let's try that. Probably work a lot better. And I have 26 packages that I can update. So let's go ahead and upgrade those. And then if you want to, you can restart a container. Okay, again, it's running now. So if you want, I want to go ahead and install. I'll go ahead and install Apache. I mean, as functionally, it's working about the same way as it would with a virtual machine, except you don't have the interfaces that you do with the others. So I want to do a sudo, and let me give it user Ubuntu, and we'll do a login. And now I'm logged in on the Ubuntu as the Ubuntu user on the container. And I can prove that I am running the 1804. So I'm actually inside of the container right now. Let's just see. Yeah, it's not taking much. 67 meg. So yeah. All right. So what I want to do is go out here to var www.html. And root owns that, so I will need to sudo to edit it. The line this is on is about 224. And what I want to do here is I want to change the welcome message that comes on the default screen so that you know this is coming from the container and not from my local machine. Okay, so then the next step is I will need to do something similar to what we have to do with Docker, which is to expose the internal port to the external, to the outside, in order for this to work. So I'm done with this. I have to, I mean, it doesn't do me any good to do it inside of here. It won't work. So I'll go back out to the host OS. And, oops. And let's see. This needs to be web server, doesn't it? Okay. So what I'm doing here is this is adding a proxy and exposing port 80 from the internal side to the external. So if I were to go out to a browser here, it's going to bring up the Apache, it's going to pass the request to the Apache web server that's running inside the container, and you can see that that is the message that I changed. That is on the HTML index.html. As far as some of the other things you can do, if you have, so you can manage remote servers with this. Like I said, so yeah, you can do that. You can also let's say that we wanted to, let's say if I wanted more information about Ubuntu, oh, I don't know. Let's do Bionic. It'll come back with a page for 1804, which is where I'm running, which is what I am running. It'll show, I think the last time it was updated, yeah. So I created, it was created and uploaded on 317, and obviously that particular one is going to expire in April the 26th of 2023, quite a ways from now. So, and then, yeah, it has a number of aliases that you can use when you're downloading. So if you just put it in Ubuntu, you're going to get the LTS release. All right, so to stop a container, and then it'll show it as being stopped. Once you're done with the container and you want to destroy it, that's it. Now, the image that's here, you can also delete that one too. And then you have to give it this fingerprint. Gone. So the next time I were to come in here and download, it would have to download it again fresh. So I've cleaned up my mess. I've taken everything out and kind of back to normal again. If there's, let me go kind of back over to here a bit. I mean, this is a really simple demonstration today. You can set up, I mean, obviously you can have more than one container in default. I could use one as a web server. I could use one as a database server if I had middleware that I needed, or if I was building up some other, maybe I have an artificial intelligence section in my system, or something like that. I can install containers specific for those, and then create the proxies in order to allow them to communicate with one another. The thing you have to remember is that these are isolated, so the only way out is, now if you're on the local system, they should be able to communicate with one another, but if you want them to communicate across a number of machines, then of course you would have to expose the ports to allow that access to happen. So anyway, that's kind of what I had today. I can't think of anything else, but if you can, if there's something that you'd want to see, or a particular set of tools. I don't know if I'll want to do clustering. I don't have a number of Ubuntu boxes, probably not enough to really do a cluster, but I could probably do one on the ARMs. The ARMs certainly do run LXD and LXC as well. So I could probably set up something to do that. Let me know in the comments below if there's something you want to see with this. It's an interesting technology. Some of my comments about it is it seems faster to me than Docker does. Seems like, I can't really judge on how much memory it's taken. It seems, it seems pretty lightweight to me. I don't see it, consuming large amounts of memory. The management of it and the ability to be able to jump in and out of it seems a lot easier. And to me, the way that LXD and LXC is set up, unlike Docker, it seems like it would be easier to maintain packages. It would be easier to maintain software pieces of code, because Docker is really a different. It's really a different design for a different purpose. I mean, it's meant to be ethereal. It's meant to be throwaway. You build it up. You do stuff with it. When you're done and want to upgrade it, you don't. You just throw away that container and build a new one with whatever new code that you've got coming down. So it's kind of different, whereas this one's kind of more of a system that would deploy like a virtual machine. It's something you'd want to have up and running for a while. So anyway, I hope you enjoyed this today. Hope to see you again soon. And please, as always, like and subscribe. Hope to see you all again real soon. And bye for now.